We'll talk about even and odd functions today and on Monday. They are going to be an essential part of understanding symmetry and characteristics of graphs, because every function can have symmetry, every relation can have symmetry, but not every function and relation will have even and odd symmetry. You have to be particular about those certain things. Thank you. So, this one's only focusing on graphs. Today is only focusing on graphs for even and odd. So this is the actual visual representation of what's happening. So recall, a graph has symmetry if it can be folded down the vertex on each side. So it means that the sides should match. Does letter A have symmetry? Yes. Where does it have symmetry? How do I write that equation?
0,
Not quite.
-2, 0.
-2, 0 because it's an x-intercept, but that's a point. I need an equation. X equals. Perfect. That's exactly what we're looking for. Any questions? He got -2, 0 because the x-intercept is the actual point in which it's folding. Does that make sense?
Will it always be X?
When you're doing symmetry, absolutely. When you're doing linear symmetry, it's vertical, so you're doing x equals because it's a vertical line. Point symmetry, it has to do with a point. But right here, this is linear symmetry, so it's based on a line. Looking at letter B, is this symmetrical? Are you sure? Does it have a vertex? So it does have symmetry if it has a vertex. Meaning, can I take this side and fold it over there and it continue on to this side? Yes. So if I were to continue drawing this line down, doesn't that mirror across this? So does it have symmetry? It sure does. Where's the line of symmetry? So how would I write the equation? Absolutely. Any questions? Make sense? Great. Now, there are two special kinds of symmetry. There's even functions, even symmetry, and then there's odd functions, odd symmetry. A function is symmetric to the y-axis. That is the key characteristic that makes it even, meaning the y-axis is the line that splits it in half. If you can't see two halves being separated or split by the y-axis, it is not even. So if I look at example A, this is not an even function because the y-axis is here and the symmetry line is here. Does that make sense? If I look at B, it is not even because the y-axis is here and the symmetry line is here. It has to be the y-axis that is creating the line of symmetry. It's reflected across the y-axis, meaning if I were to take this half over here, if I flip it, it should land onto itself. I call this a physical method of understanding. So take your left hand and put it on the left side of the graph. Left hand, left side of the graph. It's easy to tell which one's my left hand because you know there's a ring on my left finger. So, not quite, Zah. Don't see it happening for a hot minute, but I love the optimism. I said what I said. So, looking at this. If I were to flip it, it should land on this side when I move my hand. Does that make sense? So, the line of symmetry must always be x equals 0. That is the y-axis. These two things are the same. The y-axis is the name, but x equals 0 is the equation. Every point has a match on the opposite side. Example, -1, 1 should have a match at -1, 1. Meaning x should be the opposite, but y should be the same. X should be the opposite, but y should be the same. So, the way we typically write that is f of x is equal to that of f of opposite x. That's how we write this piece here. This is how you will see it in algebra. Even, notice where the V is, it has a symmetry line through it. Even. Any questions there? We're going to see actual application in a second, so don't worry. Odd functions. It's symmetric to the origin when rotated 180 degrees. So if you flip your paper upside down, it should look exactly the same. Exactly. So a cubic function is a beautiful representation of an odd function. The key here is it must cross through the origin. Let me stress that. It must cross through the origin. If it does not cross through the origin, it is not a possibility of being an odd function. This one, we don't have an example up here because these are both best represented with linear symmetry. So you'll see one in just a second. So pick a point on the graph. It is still there when you flip it. Example, if you pick a max at 1, 1, there will still be a max at 1, 1 when you flip it. Notice odd, the O means rotate. In the recall section, we said that the graphs are symmetric, but do they have even or odd symmetry? Do they have either one of those two symmetries up here? We know for certain they're not what? Because I just told you it had to be where? On the... And these are definitely not on the y-axis. Odd. Are they crossing through the origin at any point? Nope. So they can't be odd either. So this would be a no. Neither. Graph are even or odd. I'm just scooting it up to be able to see my examples, but I'm not moving the actual sentence. So, this is where your hand is going to be your best friend, okay? Everybody paying attention? Get this written. You'll need your left hand. This works the best with your left hand. If I'm looking at A, I need to determine a part of the graph that I'm going to use. I always try to stay in the first quadrant and I highlight that one piece. That one piece is going to be my marker to see if it's going to be exactly the same. So if I take my left hand and I put it on that left piece and I flip it over the y-axis and I move my hand, do I see this piece reflected over there? Then that means it has which kind of symmetry? Even, without a shadow of a doubt. Make sense? And you could do the hand method on your computer. That's why I show you that way. You put your left hand up on your computer, flip it, move it, and ask, is that same piece over there? Everybody with me? Look at B, okay? Do the exact same thing. But how do we know that? Does it look exactly the same when I flip it? Did it also cross through the origin? So it makes it odd. Because the even function requires us to have it cross the y-axis and be even when we flip it that one time. But we had to flip this twice. We had to rotate it 180 degrees. Does that make sense? So this would be odd. Looking at C, If I chose this piece right here, think about it. If I were to take this piece and flip it, is there another piece going like this on the other side? No. If it's not even, is it crossing to the origin? Then it can't be odd, so it must be. Thank you. There are 3 possible answers. No more, no less. It's either even, it's odd, or it's neither. Any questions there? Looking at D, highlighting my piece right there. So I know if I flip it, there's nothing in that quadrant that matches it. So it can't be what? Even. Can't be even. But can I rotate it to see if it looks exactly the same? Does it look exactly the same? So it makes it what? Perfect. Y'all are doing great. I mean, he took the compliment. Looking at E, focusing on that one piece. If I were to flip it over the Y, is it reflected on this side? So it can't be. Does it cross through the origin? So can it be odd? So it must be. Thank you. Y'all would think that y'all in my Algebra 1 class, how good y'all are doing this. I'm not gonna lie, some of my Algebra 1 students struggle with this. And usually, this class sometimes does it. But this is the first time of me using this setup of how to talk about it, in the sense of your notes are completely different than all the notes I've used for the past 6 years. If you go back and look, their notes do not look like this. So the methods of me talking to them are the same, but the notes really didn't match what I was trying to teach. It was too much at the same time, okay? So, any questions there? Let's look at F. Focus on one piece, okay? Right there. If I were to take my hand and flip it, does it what? Does it match over here? No, because it would have to be another one going like this. So it's not even. Does it cross through the origin? Let's rotate the paper. Does it look exactly the same? So this must be. Thank you. Any questions there? Please don't go about rotating and twisting your computers. Be gentle with them. If you get questions like this and you try to rotate to see if your graph is still the same, I don't have time for somebody throwing their computer at someone. Thank you. I've seen it, so that's all I need to tell you. Oh, I've seen it. It's just a full rotation, no stop, no breaks, and it just flies and hits the next person. So please be mindful, okay? Any questions? What I need you to do for me is do questions 1, 3, and 4. Guys, do it 1, 3, and 4. I'm giving you 8 to 10 minutes.
So we just like even.
Yeah, absolutely. That's what the directions say, yes? Do exactly what the directions say. We're learning how to read, right? Don't overthink it. Hush, child. You heard me. Hush over there. Wait, it's better to have that and that. Make sure you're 100% sure before you give that to me. You know it's a grade going in as is. I ain't cushioning nothing. Actually asking the question, is this even, odd, or neither? So if I'm looking at number 1, I'm going to highlight a part that's at the top first quadrant. That's the first thing I'm highlighting. The actual piece in the first quadrant. Now everyone, take your hand. Don't wait on my hand. Take your hand, because my hand is not yours. My knowledge is not yours. Remember, I've already mastered this. That's why I'm able to teach you how to master it. But you have to physically do it. Put your hand on there. People going, well, I'm left-handed. You ain't writing right now. You're applying right now. Kingston, make sure you're leaning up, honey. Kingston, lean up, baby. Arms out. Let's go. Arms out, come on. Feet flat, that way I know. Lean up, feet flat, come on. You know what to do. If you're sleepy, you got to grab what? A clipboard, because we don't want to go to the other option, which is the blue chair, where you can sit outside and wait for Mr. McNeil.
That's a what?
That is a blue chair. That is a write-up. That means I will pull out one of these pretty little pink papers right here and write up that you're not listening to me. And I don't want to do that, because that's no fun. Okay? That goes for anybody. I give you an option to stand up and wake up, go get water, do what you need to do. But you don't need to be sleeping in a math class that's helping you pass and helping you be better for Algebra 1 next year. Because then you're wasting my time and your time. But really your time. I already did this. So hands flat on there. Hands flat. Left hand. Put it on there. Especially we made 33s and zeros. We got to get better. You take it and you flip it completely. It should be flat to the other side of the y-axis. Keep it on the actual graph itself. Then when you slide your hand away, do I see a mirrored image on this side? So it has symmetry to what? The y-axis, which makes it, thank you. That's how you answer this question. Look at number 3. Do the same thing. This entire thing is in the top quadrant. Not a part of it, that whole thing. We take our left hand, lay it flat. Let's go, let's go. Other way, Colin, left hand. Left hand on the left side of the graph. You take it and you flip it. And then you move your hand. Is this peak picture mirrored over here?
No.
Then is this even?
No.
Absolutely not. What must be true for it to be odd? It has to go through the origin. Does this look like it's going through the origin?
No.
So is this even, odd, or neither? Neither. That's not how that works. It's 3 questions. Either you made a 0, 33, 67, or 100. So, any questions? Number 4. Put your left hand down. Let's go. Left hand, true. Left hand. You're okay. You flip it. And you slide it away. And you ask, is there a line going towards that corner of the graph that mirrors this one? So is it even?
Yes.
No, because you just said no to that first question. Listen, logically, okay? Then, is it going through the origin? Because isn't this the origin right here? Is that going through there? Yes. Then you need to flip the page, rotate the page where it's completely upside down, and ask, is that the same picture we just highlighted over here? So it has symmetry to the origin, making it what? Do we see where the mistakes were? Thank you. Look at number 2. I want to talk about this one. This one should not be complicated, because didn't I just show you multiple ways to look at it? My question here is, highlight that. What do you notice about this graph compared to this graph?
It's only one line.
It's only one line, so can this possibly have symmetry?
No.
Then be for real. What's the answer? Thank you. So what's hard about that? Nothing hard about it. You determine the difficulty of your understanding based on your perception of what is hard and what is easy. Y'all think an answer being like this is easy for people like me and Miss Davis, because we look at it and we say, if there is no other half, how can there ever be symmetry?
Can we do 5 to 10?
No. I'm choosing what we're doing because I know what needs to be covered. You just don't want to use logic. Look at number 6. Instead of using the left side, because there's nothing in this one, I'm going to use the right side. So when you switch sides, you have to switch hands. So instead of my left hand, I'm using my right hand. Lay it flat on that right side.
Right.
If I were to flip it for yourself. Slide that hand out the way. Is there a mirrored image in this quadrant?
No.
So is it even? No. But if I took this image, is it crossing through the origin?
Yes.
So that's already 1 plus in our corner to potentially be odd, correct?
Yes.
But then I need to rotate this all the way upside down. Does this match the original picture I highlighted?
Yes.
So it has symmetry to the origin, making it what? Odd. Feet down, baby. His computer's in there.
Me?
No, I was talking to him. Baby, you have nobody in front of you. I mean, valid question, but it's just you. No, you're okay. I'm not judging. I ain't judging. Look at number 7. Highlight your left part. Now, this one's a bit different than the graphs that we've been dealing with. What makes this graph different than this graph up here? Closed circles. One has arrows. That has arrows at either end. It's assumed it's going on forever. But this one has endpoints. So, left side, left hand.
Left side, left hand.
Exactly, because we're flipping to the left side. Take it and flip it. Do we see this image mirrored over here? No,
Short. No. It's short.
because it's shorter than this side. So does it have symmetry?
No.
So it makes it what? There you go. We knew automatically it wasn't odd because there's no other piece below it to mirror it when we rotate it 180 degrees. Any questions? That's what I mean by logic is something that helps a bunch when there's no calculator involved. Sometimes you have to ask what makes no sense, and that leads you to your answer. Any questions? But if I looked at 8, and I highlight that side, which hand am I using?
Left.
My left hand, because I'm flipping to the left side. So if I take it, and I flip it, and I move my hand, do I see a mirrored image of what I highlighted?
Yes.
Exactly, all the way to the open circle. So does this have symmetry to the y-axis?
Yes.
Which makes it what?
Even.
Absolutely.
I'm down that way.
Any questions? So, I want you to see what you know based on the rest of these because a lot of them mirror exactly what I talked about, precisely that. But quick question, without doing any highlighting, look at number 16. I want you to use logic without any highlighting. Okay? Is this even, odd, or neither?
Neither.
Neither. Because there is nothing to mirror to this side that would match. And then there's nothing to rotate from here to here that would match. When I turn it upside down, does that look like what I started off with? Absolutely not. So, that was neither. You see how you didn't even need to highlight for some of these? It's just common sense. I want y'all to start practicing that because not all sense is common. But I'm going to help you get there, okay? The best way I can. Any questions? You got some time? This should be finished, okay? These are not complicated questions. You don't need your calculator at all. Go through, highlight, try to finish it. That way you have nothing to do this afternoon except turn it in. I know that weakness needs to be fixed because it hurts your grade more than failing a test.